What's going on, guys? Your everyday math tutor here, and in today's video we're going to be looking at 3 common limits that you're going to be seeing in the AP Calc exam. So the first one, let's go over it here. The limit of x squared minus 1 over x minus 1 as x approaches 1. So obviously when we substitute 1 into the function, we're going to get 0 over 0. So that's something we don't want. The second thing I'm going to ask myself after I know you can't have 0 in the denominator is, am I able to factor something out in the function itself? And in fact, I can factor something in the function, and that is I can factor out the top, the numerator, so that I have, let's see here, the limit of x plus 1, x minus 1 over x minus 1. And as we can see here, we can't forget about the x approaches 1. As we can see here, the x minus 1 will cancel out. It becomes 1, so we are then left with the limit of x approaches 1, or sorry, we should say the function first, x plus 1 as x approaches 1. And now we can substitute the 1, and we get 1 plus 1, which is 2. So that is the answer for the first limit. So again, you end up with 0 over 0. And then I ask myself, well, can I factor something out? And I can, and I did. And then eliminated those x minus 1. And we were left with x plus 1. And then I can substitute, and I have no issues then. And I just get 2. Now let's take a look at the second example here. I have the limit of 3 plus h squared minus 9 over h. Again, we are left with 0 over 0. And I asked myself, can I factor something out? Well, I can, but I think it's best if we expand this, this term over here. So that's exactly what we're going to do. We're going to expand the numerator. Because what we're going to do then is we'll see that something will cancel out and we'll have an h that we may be able to factor out then. So let's go ahead and start it here. We're going to have the limit of, and when I expand this term here, whoops, erase the whole thing, meant to use the laser here. When I expand this parentheses here, I'm going to end up getting 9 plus 6h plus h squared. And that is the expanded form of that parentheses there. And then I just have minus 9. And then over h as h approaches 0. But still, I cannot substitute 0. So the next thing I'm going to do is combine the like terms in the top. That is 9 minus 9, which is 0. And I am left with the limit of 6h plus h squared over h as h approaches 0. Now I can see that the h could be factored out on top. So I'm going to write the limit and then factor out one of the h's. And I'm left with 6 plus h over h as, looks like an n there, as h approaches 0. Now you can see in this new function that the h's can just cancel out. So that becomes the limit of just 6 plus h as h approaches 0. And when we substitute h now, we won't have any issues, and we're left with 6. So that is the answer for the second limit. I was about to say the first one. I forgot that was the second one we're doing. And now here's another common limit that you're going to see in the AP exam. So here, it doesn't look like I can factor anything out. And I obviously, once I substitute t is equal to 0, now it's going to obviously give me 0 over 0. I can't factor anything out, and I can't expand anything. So what I need to do now is when I have a root, and then I have a constant, I can multiply by the conjugate. So that is the root of t squared plus 9. And instead of having minus 3, I'm going to have plus 3. And I'm multiplying it by 1 here, so I'm going to have the same at the bottom, the root of t squared plus 9 plus 3. And now we multiply across. So we'll multiply the numerators, and we're left with the limit of, this is just going to be t squared plus 9 when the roots get squared. It's just going to be whatever's inside. So we have t squared plus 9. And then we are left with negative 3 times 3, which is just negative 9. So that is what we're left with in the numerator. What we have in the denominator now is just going to be t squared. We won't actually multiply the denominator. We'll just leave it as is. So it's going to be t squared multiplied by the root of t squared, the root of t squared plus 9, and then plus 3, parentheses. And of course, as t approaches 0. I like to write t approaches 0, or the value that's it's approaching at the end, so I don't read out the limit first, and I instead read the, anyways, who cares? But we have here, we can simplify the numerator now and be left with the limit of just t squared on top over t squared parentheses the root of t squared plus 9 plus 3. Okay. And now we can see again, just like we had the h, these t squareds can cancel out. I cannot forget about the t approaches 0, as I always do. But after they cancel out, we are just left with the limit of 1 over the root of t squared plus 9 plus 3 as t approaches 0. So what happens now is that when I substitute 0 into the equation, I'm going to have 1 over 0 squared, which is just 0. And then I'm left with just the root of 9 plus 3. That is 1 3 plus over 3 plus 3. And that's going to equal 1/6. So that is the answer to the third limit here. So what we did for the first one was we multiplied by a conjugate. Or the third one, I should say, we multiplied by the conjugate because we saw root. And the second one, we just expanded. And the first one, we factored. So those are 3 common limits that you will see in the AP Calculus exam.